All right, we are on day 2 of triangle similarity. So this day 2's success criteria is that you can identify corresponding angles and sides of a triangle is what our whole goal is for that one. So the second one here, okay? And so we're looking at what we call proportional sides and congruent angles that are corresponding. And so we're going to look at a couple things. This is kind of a precursor to show that the triangles are similar here. So we're going to kind of introduce this, talk about some vocab words as well. The biggest thing is you need to know the corresponding sides, and you need to know when they're proportional as well with the sides, and then you need to know corresponding angles and when they're congruent as well, okay? So what does it mean for triangles to be the same? Or sorry, not the same, similar. This would be the same shape, and then similar size, or sorry, same shape, different size. So it can either be bigger or smaller. We can have that scale factor with reducing or enlarging, one of those two, okay? So triangles have, they have sides and they have angles for each of these. So again, they have sides and we have angles, and those sides and those angles for each of these, you need to make sure that the sides are going to be proportional and the angles are going to be congruent. We're going to talk about those. And then they also have vertexes, which those vertexes are those end points that they have. Okay? So we don't need every single thing for this, for them to necessarily be the same size, but we're going to look at this and we're going to be able to show that they are proportional that way, okay? And we'll go that route. So a couple other vocab words that we have. Again, we're going to look at similar triangles. We kind of already talked about this right up above here, that these are going to have the same shape but different size. So the same, again, they're going to be the same shape, meaning they have to be that same triangle with the right angles and that the correct angles and that kind of stuff. But again, they're going to be different sizes that we've talked about already. My corresponding angles are the angles in the same location. So these are angles in the same location. It's all about location with corresponding sides and corresponding angles. So this is all about location as well. When they're proportional, that means that they have the same scale factor. So we're looking to see whether or not these side lengths are growing at the same rate or the same proportion. Okay? So we're going to go through a couple examples identifying corresponding angles, corresponding sides, and then we'll talk about proportionality here in just a second. But let's look at just corresponding sides and corresponding angles. So first example right here. If I have triangle ABC, so this is a little bit of notation here, and then this middle sign here, this little tilde sign, that's similar, instead of having to type this all out, is similar to triangle DEF. They put this in order for a reason. So if I have triangle ABC, that means angle A, and this sign is congruent, is going to be congruent to angle D because it's in the same spot. So first spot, first spot. Those two angles correspond to each other, so they're putting them in a corresponding side. Angle B would be congruent to angle E, meaning it's going to be equal to E, and angle C would be congruent to angle F. So these are my corresponding sides, and if they're similar, if we have similar triangles, that means that they have to be the exact same angle. Meaning if angle A is 30 degrees, D better be 30 degrees as well for them to be similar, and all the others there as well. If I look at my side lengths, AB, if I do proportions, again, proportions are going to be like that new that we talked about the first day over old. So these proportions, these scale factors have to be the same. So if I take the side length from AB and divide it by the corresponding side length, with AB would correspond with DE. When I divide those, it better be equal So this scale factor better be equal to BC over EF, and it better be equal to AC over DF as well. So meaning that when I divide this, if that it gives me 2, then all of them have to give me 2. If it gives me 0.5, they all better give me 0.5. Okay? Again, a couple things to remember. Please remember that corresponding angles are always equal, and corresponding sides have the same ratio. This is what we call proportions. This is what we call congruent. Again, another word for equal, if you want to think about that, is congruent. And ratio would be proportional. Okay? So if we go down here, we're going to fill in the blank here. Similar triangles have the same. This just should reiterate what we have. This is going to be the same size. Or sorry, same shape. But different size. Okay, corresponding angles in a similar triangle are always congruent. Okay, corresponding sides in a triangle are proportional in length. So we're just reiterating some of these things that we learned up here. This sentence here, if triangle XYZ is similar to triangle RST, then angle Y matches with angle, again, you should say S because that Y is in the middle, S, that's important that we line these up so we can communicate without having the triangle. If triangle XYZ is similar to triangle RST, then side XZ, so that would be XZ would have to be the same as R and T. So this would be side length, again, RT. We put that side length over. By the way, this would be, I guess they have angle inside here, so, but if you're doing angle, that's the symbol for angle. So, all right, so we should be able to match. These should be able to match everything that you got here. So L should go with angle P, angle M should go with angle Q, angle N should go with angle R. And then I should be able to match my corresponding sides. So LM would match with PQ. MN would go with QR. And again, it's just where they're placed. That's all we're looking at. And then LN would go with PR. Okay? Okay. So if we look at here, identifying corresponding sides and write a proportion for down here. So if I look down here, I've got AB is 6 centimeters. Again, if you want to draw it, you can, but you shouldn't have to. And then AC is 9. DE is 12. And DF is 18. So if I actually put numbers here, AB divided by DE, which that would be 6 divided by 12, should be equal to AC, so that would be 9, because AC, and DF, which would be 18, which if you simplify those both give you, this would just be 1/2 is equal to 1/2 if you simplify that. And so my scale factor, again, depending on which one is old to new, so what is the scale factor from AB to DEF? So we would go new to old in that case, so the new one is D, so this would be actually 2 over 1 because we're getting bigger, not smaller. Okay, this helps me find my corresponding sides and to see if they're proportional. To find my scale factor, I have to go from here to there because it's new over old, which I'd have to go like 18 over 9. Okay. And then a couple short answers. What are corresponding angles and corresponding sides in triangles? And why is it important to match the numbers in the correct order when labeling these? So corresponding angles and corresponding sides are in the same position. So think about position. Again, this is all about the position that they're at. And why is it important? It's important because if we don't match the correct letter, then all of a sudden we're not going to see whether or not they're proportional or see whether or not they're equal as we go forward on day 3. So that's important as well. So, okay? All right, we'll see you later. Bye.